Today we are doing 3-2, solving systems of equations algebraically. So we're moving past the graphing. I think algebraically is a better way of doing it, definitely more accurate. Today's date is today, and we are going to be solving systems of equations using substitution or elimination. So, first one that we're going to go over with is substitution. I'm not writing this down, but you might want to make a note of this. Substitution works best when one of your variables is already solved for. And if I look at that first equation, x isn't solved for, y is not solved for, but this y right here has a coefficient of 1, so that's going to be pretty easy to solve for. And if I were going to do that, I would just subtract 2x from both sides, and then divide everything by -1. So I get y equals 2x minus 7. So what's going to happen then is I'm actually going to take that equation right there, that 2x minus 7, because that's the same thing as y, and I am going to substitute it into the other equation wherever I see a y, because y and 2x minus 7 are going to be the same thing, because they have an equal sign in between them. So then, when I do that, I'm going to get 4x plus 3 parentheses, 2x minus 7 equals 9. That's just a standard algebra equation. Distribute, combine your like terms, get your constant to the other side, divide by 10, and I get x equals 3. Well, I'm only half done. I've got the x. I need to figure out what my y is going to be. So to get that y, you just are going to substitute that in. I'm going to substitute it into this equation right here, 2, and I know now x is 3. And I get y is going to be 6 minus 7, which is -1. Be careful not to leave it like this. This is a system of equations. We want to make sure that we give our answer as an ordered pair. 3 is first, -1, our y comes second. And this is our answer. What that's saying is if I were to graph those two lines, that's where it's going to be crossing. So let's go ahead and do another one. I've got x minus 4y equals 1 and x plus 2y equals 13. Typically, I probably would not use substitution on this one, but I'm going to on this. I went ahead and I solved for x, and looks like I got x equals -2y plus 13. All I did was I subtracted 2y from both sides of the equal sign. So what I'm going to do is I'm going to make that substitution into the top equation, into my other equation, wherever I see an x. I'm going to put in -2y plus 13. Go ahead and do that. I'm going to combine my like terms. I subtract the 13 over to the other side. It looks like I kind of combined two steps in one. Divide by -6, and I get y equals 2. Well, it only tells me half of it. I need to know what x is, and I always go back to the equation that I solved for. X is going to equal -2, and our y is 2, plus 13. So I'm going to get -4 plus 13, which is 9. So make sure you get that as an ordered pair. And when you do that ordered pair, make sure your x-coordinate always comes first. 9, 2. That's it. All right, we're going to do some elimination. Elimination, our whole goal is to create opposite coefficients. That means you've got the same coefficient, different signs, one's positive, one's negative. Because we're going to add those together. And when you add opposite coefficients together, you get 0. So on that first one, we already have, it looks like, some opposite coefficients. Positive 4, negative 4. What's going to happen is they cancel out. And then I add the equations. 2x plus 3y, or 2x plus x gives me 3x. 18 plus 6 gives me 24. Divide by 3 and I get x equals 8. And then you just take that, and it doesn't really matter which one. You're going to take that 8 and you're going to substitute it into one of the other equations. Looks like I did the bottom equation here and got 8 minus 4y equals 6. Solve for y. And as always, we want to make sure that we give our answer as an ordered pair. 8. I could either do it as a fraction 1/2 or 0.5. Let's go ahead and do another one. If I notice over here, I have a negative 3x and a positive 3x. If I add them together, that's 0. They are going to cancel each other out. 5y plus y is going to be 6y. 6y equals 24. Divide by 6 and you get y equals 4. I went ahead and plugged that into the bottom equation. Right there, 3x plus y. Instead of y, I wrote 4 equals 8. Subtract 4 from both sides, divide by 3. And as always, I want to make sure I give it as an ordered pair. 0.75. If you wrote 3/4, that would be perfectly acceptable. And there's my answer. Oops. Skip those right now. On this one, I'm going to let you choose which way to do it. This is going to be an honors class, so I'm going to let you choose whether you like substitution or elimination. Sometimes one is going to be better to use than the others, and it's going to kind of be up to you to figure out which one is going to be the best. So on the first one, I noticed that b is set equal to on each of those. Well, what's going to happen is I'm going to set those two equations equal to each other because they both equal b, therefore they have to equal each other. And I get a equals 8. Subtracted a from both sides, added 5 to both sides. So once I know what a is, I plugged that in to the bottom equation and got b equals 11. When you get variables that aren't x and y, you're always going to want to go alphabetical. A comes first, B comes second. All right, let's do another one. I've got 4x minus 2y equals 11, and 4x plus 3y equals 6. Well, unfortunately, I have the same coefficients on this one. I don't have opposite coefficients. So what I'm really doing is I'm going to multiply that top equation by -1. And when I multiply that top equation by -1, it changes the sign of everything. And now I have a positive 4x and a negative 4x. I add those together, they're going to cancel out. And then 2y plus 3y is going to give me 5y. Negative 11 plus 6 is going to give me -5. Divide by 5, y equals -1. Choose one of the equations to plug it into. I chose the bottom one, and I got 4x minus 3 equals 6. Add 3 to both sides, divide by 4. This is an example where graphing would really be not a very accurate way of doing it. 9/4. I'm not sure that I could be accurate enough on a graph to get 9/4 or 2.25. And there's my answer. All right. On this one, we've got an internet provider offers 2 different plans. One costs 2 cents per email plus 9 cents monthly service charge. The other costs 5 cents per email with no service charge. Let's go ahead and write a system of equations. I'm going to let C equal the final cost, and E is the number of emails. So, for the first plan, it's 2 cents per email plus 9. That would give me my total cost. For the second plan, it's just going to be 5 cents per email. So, how many email messages before both of them cost the same? Well, that would mean that the costs are equal, so set them equal to each other. And I subtracted 0.02 E from both sides and got E equals 300. So that's kind of the break-even point. So if you were to receive 500 emails, which one would be better? Well, I would just take that 500, plug it into both equations, see which one works better, which one's going to cost you less money. All right, I hope you enjoyed some graphing systems of equations. See you around for 3-3.